All right.
Hey, um, so today we'll try to modify the simple NFT contract to make it support approvals per token. And we can probably do this with a simple way first. So, because when you delete an approval, you need to clear, or like when you transfer a token, you need to clear approvals. So this the smart way of doing this is probably to iterate on all approvals that you have right now for this token and delete them, which means it is okay to store approvals either as a hash map or as a vector. So account ID, so, and this is going to be a vector of account ID. The reason why you don't really need a hash map, and if you want to keep the order, is because you're still deserializing all of them. And the reason why you don't use an ordered map is because you have to iterate through all of them when you transfer this given token, because you need to essentially revoke all approvals. So that's why it is okay to use a simple vector. So right now metadata is here. So this is not balances, but
So just to recap, I'll pretend to be I'll pretend to be Chad or something, and I'll put it into English. So, um, the reason why you've chosen to use a vector is because what we're sort of doing is we're thinking ahead. Each time we transfer a token, we're going to need to dip in and we're going to need to iterate all of the account IDs anyway and check if any one of them has an approval. So that's one. And then if one of them does have an approval and we're going to go ahead with the transfer, we're going to need to basically get rid of or revoke all of the approvals anyway.
correct, yeah.
So with an unordered map or like a hash map or whatever, we would be kind of wanting to surgically go in and just talk to one entry and then deal with that entry. But in this case, we're not.
Yeah, we can use a hash set, like probably like for this example, it doesn't matter. It might have a different order at which you add approvals, but it's probably not a big deal. Uh, it would work for us anyway, so that's easier code to write, and we can think about like optimizing it later. But it is not a persistent collection, so it has to be um, because we need to clean it up at the transfer. So um, so this is the token that we'll work with, and now we have tokens per owner. This was called accounts, but this is really tokens per owner. Um, and finally, what we really need is, so let's move. So there was a method that was doing computing the initial storage when you mint a token. So let's call it measure token cost. Mint token storage cost. So this is for ownership. And this is how we do this. So we self, and let's just use a repeat 64 because you don't really care about the amount of gas you do. So we have this method of prefix, let's call it unique prefix. Tokens per owners and tokens by ID, I guess I can call it, to avoid confusion. So measure. Cool. So this kind of few updates that we originally needed to do. So let me explain what's going on here. And this is essentially how much it's going to cost you to put an object into tokens per owner, a new object of the maximum size. And so let's say my owner ID is ek.near, like very short ID. And then if I want to later transfer to Matt, Matt's account, let's say mattlocker.near or something like this, like longer, he will consume extra bytes for doing it because he needs to pay for the storage that is taken by tokens per owner plus account ID and an ordered set. I guess we also need to, what is this magic? So this probably was for the owner ID here in the actual token. So the extra cost is the difference in current usage minus the original usage plus the amount that you would pay for a longer owner ID when you store the owner in the top level map. Approvals are currently empty and we don't care. Metadata, we will pay for this once, so the rest will be fine. Okay, so next method is mint. I actually can look at the mint.
Can we go back to that storage thing one more time? Sorry.
Yeah.
Um,
so let's actually write what it is. So let why we insert it in here? Yeah, that doesn't make sense. This should be self tokens per owner insert.
yeah, and then at the bottom you've got self accounts.remove. So this is, I was kind of confused by that, and now it's tokens per owner, right? Yeah.
This is a correct one. So you need to insert it into the tokens by owner.
So we're just including that unordered set and then some, for some token ID, right? But some really big account name. Yeah.
Yeah.
Tokens per owner, big account name, some unordered set with the unique prefix of the big account name.
Right. So the unique prefix is also not a fixed size. So we use O. And then account ID, I guess, without hashing it. I'm not sure. You want to do this? Um, because now you have variable prefixes based on the index, so maybe you want to just hash it here, so you can hash this. But then you also want to put it in a vec. So this will be fixed size, so you don't need to worry about prefix from every variable. Like you have one less problem to worry about. So this is going to be vec with capacity. For some reason my CPU is going wild. You would push a unique prefix, something like O or B, O, and then you would add the hash, and then you just return this prefix. Second, I need to check what's going on because my CPU just going crazy, and I want to know if this is something that I can fix. Yeah, it looks like it's C-line. For some reason, it thinks that I'm doing something expensive here. Anyway, okay, so unique prefix and an ordered set is now a fixed size. So this is fixed size. It doesn't matter which account we use. 1 second.
Your computer okay?
Yeah, my cat wanted to leave the room. So we insert in a map the maximum length and an ordered set of empty size. So this will cost us some size. The problem is now if I upgrade if I do this operation by owner, I need to account for like token ID cost or something like this. And if token ID is relatively long, then it has to be accounted. If token ID is short, it has to be accounted.
What is the type of our token ID right now? Is it a string?
Token ID is, I think it's a string, yes, for this example. Okay. Yeah, so first NFT will be slightly more expensive potentially than the next NFT for the owner. Because if owner doesn't have an account in a lookup map, then the owner will pay for the lookup map creation plus the like extra cost that already includes this lookup map creation. So so what we need is we can say token by owner entry in bytes, and this is going to be this value. So we measure the size of token per owner entry in bytes. Now what we need is we need to measure owner owner ID extra cost, like in bytes. So this is this value. So in a token record, we have owner ID. So when you first insert a token, you mint a token to yourself, let's say, then the cost will be blah, 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 your token ID links. So this one is extra cost for longer account name. So I don't know, it's kind of messy the way
I
we're
get
doing
it.
this.
So what you're saying is like so are you saying the owner is going to mint the token, but then they're going to immediately transfer it to someone else, or
No, they don't need to transfer to someone else, but we will measure the cost of minting this way. So let's actually do the mint first. So you have token ID, you have meta, and that's it. So I can call it metadata. And you have a hash map that is currently empty, this approvals map.
Yeah.
So let's do, instead of Yocto, we'll do payable, and we'll do a transition for owner by measuring their storage and do a refund. So the token is kind of, the owner will pay for the storage. So what we do, we say, okay, let's insert this token and make sure that the previous token doesn't exist. Now we add the ownership token set. So we need to add the ownership to the owner of this token. So say the token is owned by the current owner ID of the contract. So this is going to be tokens per owner. I guess it can be tokens by owner instead of per owner. Okay.
So I have a quick question. So about minting, when we
Yes.
mint, can we not simply transfer directly to the user that we want to mint to? And in that case, shouldn't the cost of our, so we want to maybe get an absolute max cost of what it would be to mint, right? And so the owner ID should be like the longest account name, and all of this stuff. Like
Yeah, so this is what we actually doing here. Like in the original measurement, we measured how much it's gonna cost to mint by the longest account ID, but
okay,
we don't want to give it to this owner during the minting and then change it. Instead, we're doing like, let's basically mint a token to the real owner and no approvals, then add this token ownership to this account ID, to owner of the token, and the token ID, we increase supply, and now we need to measure how much it cost. So this is where we do a refund logic, except we only increase in storage, so we don't do refunds. So we say new token size in bytes, is, so we take this plus this, I guess minus this. Now we do storage cost, required storage in bytes. And this is going to be self, whatever extra storage plus how much we spent. Does this make sense?
Yes.
Cool. So now we just do let required cost, which gonna be storage price per byte, and wait a second.
So just to recap, extra storage in bytes per token came from the original calculation when you created the contract of how much it would cost to add the unordered set per large account or whatever.
Yeah, exactly.
Yeah, and then you're going to combine those bytes with the bytes of the token that the user wants to create, because of course the string metadata coming in is like some random.
Yeah, and the token ID can be like very large as well, depending on how user want to represent the token. So this is a required cost.
Yeah, okay.
So now we say, well, let's see what the owner attached. So you have attached deposit.
And then as long as it passes the assertion, we'll basically accept it.
Yeah, we say, okay, now that required cost should be less than equal than attached deposit. And then we can say required to attach blah. Actually saying this. Next.
And just to recap for anyone else that's watching the video, once basically, if we get to the end of this function and the assertion fails, we're going to unwind everything we've done, right? All of the storage, minting, blah, blah, blah.
Right. So let's say this assert fails, then entire method fails. So all of this storage modification will be reverted up to the moment when it was started executing. So we know that.
See, everybody, it's not that hard. It's not that hard. You just have to be like Eugene the Dream.
So we say, okay, how much we need to refund, and then if we want to refund, then we will do promise new self. Well, actually, I guess you can use the predecessor again. And we just transfer refund.
Yeah, definitely not for this example, but I just want people to know, like, as well, like, this is exactly where you would build in like a fee model. So for example, like if you had a flat fee per minting NFT, so like you were going to take like a flat nominal fee of like 0.1 near every time somebody mints an NFT, you would need the user to attach 0.1 near, or actually above 0.1 near. And then you would figure out how much storage costs are going to be, and then you would charge 0.1 near the fee plus the storage cost. Then you'd refund them anything else, right?
Yeah, and we can return something. I don't know, what do you want? It can be a token. We can return a token. We can return a token ID. Since you passed us both of them, we kind of don't need to return anything. We can return total supply. So for now, we're going to return nothing. So this is minting. Burning is a little more complicated. And I'm not sure what is details. So maybe you need to own the token in order for this token to be burned. Can other people burn it? But when you burn a token, you probably want to do refund of the storage if you wish.
Yeah, I don't think we should tackle that. I think we should tackle the approvals and then how
Yeah,
much.
let's do.
Yeah, how much should be attached? Because approvals is going to be a payable because of security anyway. Because you're going to approve some other account to transfer your NFT, so you should have to attach
So
something so that you have to confirm it.
So these two methods, I don't need to modify them. So this basically, when we transfer a token, we add the ownership in a token set and cleans up the token set if it was not there at the removal time. And the transfer is actually what's interesting is how we actually transferring it. So I think this method is in NFT core. So we need to modify NFT core and add extra fields. Enforce owner ID, and this is, as we discussed, this is required with approvals or without approvals. It's a security. I think memo can go last since it's probably easier. So in this case, message. So we like to keep the order of the fields the same for transfer call and for transfer in a fungible token example.
Just a random quick syntax question. NFT transfer call. Is it possible to have optional options and then message which is not an option like after? You just have to go like null.
Oh, because it's JSON.
Oh, okay.
You have to like name them, but you can skip this too. So basically, you don't need to have them. It's gonna be considered a non-option.
Got it.
Cool. So resolver, blah blah blah. All right, so we need to add this extra field that was introduced, enforce owner ID here.
Oh, and just so everybody knows, enforce owner ID. What we're going to do is we're going to add a bunch of approvals. So you might approve your token on marketplaces A, B, C. So 3 different marketplaces. And what we're trying to safeguard against is that when marketplace A and B both try to do a transfer at the same time, marketplace A is going to transfer and change the owner, and then marketplace B is going to try to transfer. But if we have the transfer with the flag enforce owner ID, basically marketplace B is going to try to pass in the owner ID and it's not going to match. So basically it's going to fail. So that's kind of what we're trying to safeguard against, right, Eugene? Like a race condition here?
Yep. So so there's no way to iterate on the tokens, which is kind of unfortunate. So maybe we should do an ordered map here, so you can iterate by tokens. And it doesn't change a lot. What's going on? So I'm adding also a few view calls, so you can get a token, then you can get I don't know if it's needed, but let's actually not do this. But what we may need is 2 calls for approvals, so let's include them in core as well. So one gonna be well, actually they will be returned at the token request, so you don't need to view approvals. So what you need is add approval, or I guess we can call it approve account ID, and that will be account ID, valid account ID. and then for tokens. So token comes first, token ID, and then you have approval that will return bool, similar to set. So when you add an approval and there's already an approval, it will return false. If it's a new approval, it will return true. So same we're gonna do, I guess, revoke account ID. Well, kind of approve access, or like approve token. Let's just ignore the names for now, but this works the same way. It should revoke the approval. Cool. So first, let's fix transfer. So in transfer, we'll do the following. We have a sender, receiver token. So now you need sender. I guess you need token ID. And now you need to enforce owner ID here. And so enforce owner ID, it can be also account ID, option of account ID for some reason. How I do this? That didn't work because it's saying I got my valid account ID. And you don't want to have a valid account ID. Well, let's actually do valid account ID. I don't care.
This the valid account IDs have been giving me some headaches. So I'm interested.
All right, so that now works. Since I don't need it here, but maybe I will need it later. So let's first fix internal transfer. So we're saying sender and receiver should be different. This is not the case because the owner might be not the sender. So the escrow marketplace on which it acts, it can pull it. So it should not be checked here. So we basically say, oh, sender should own the token. Well, not the case again. So what we need is we have the owner ID. So this is this record. What we need is it should be if let enforce owner ID.
And then we're going to check the approvals, right?
Yeah. So yeah, let's first check that the sender has access. And this way we can do if sender ID equals to token ID, or token approved account ID contains sender ID. We are good. So like, okay, so we basically should panic if it's not the case. So not equal and doesn't contain, we say, oh, let's panic. Unauthorized. So if sender is not the owner and the sender doesn't have approvals for this token, we say let's panic. It's not allowed.
I have a quick question about gas. So, you know, if the sender is the token owner ID, right?
Yeah.
wouldn't we just branch here and handle it as the owner, which is cheaper than basically starting to talk to the vector about and
No,
start
that
to
one
ask the
is not
vector?
gonna execute, so it will be ignored.
Oh, so if it's just
Yeah, if this one is false, it will break early.
right, okay, and it'll just panic.
So
Okay.
here's a check. This is not a sender. What we really
Yeah.
need to check is if owner, token owner, and the receiver, token owner and the receiver should be different. Cool. Any. So this one we checked. We are good. So now we need to remove it from the owner, which is this account, and add it to the receiver, which we did. Then we do now receiver is this, and we also want to do approved accounts. We just clear it. So we say, okay, no more approvals, so except for the owner, the new owner. And this is it. So we say and transfer it from, well, that's a problem because the owner already changed and sender doesn't match it. So let's say we're good here. Transfer from token owner to receiver. And we don't say like on behalf of blah, but we may need to say it, but that's fine for now. So then we clean it up. And if there was a memo, we also drop in the memo. And I forgot to enforce owner ID. So we should do if let's owner ID, then we should do assert EQ token owner. The token owner is different from enforced. So it's terrible. Like since we're doing not type errors, there's going to be a lot of mess that is complicated right now. But yeah, here's a transfer. So we're pretty much done. We enforce the ownership. We drop the memo.
Let me just run through it once in just English and just see what happens. Okay. So what we're gonna do is we're gonna get the token object. Then we're gonna check whether the sender ID, if the sender ID is not the token owner ID and there's no approved account ID on the token for the sender, the person who's trying to send it. So it could be a market that's trying to send it. We're gonna panic. Basically, if we cannot find an owner or an approved account ID to send, then we're gonna check the enforced owner ID. So basically, if it was a marketplace, it should have passed on the owner that it's trying to transfer on behalf of. And if that enforced owner ID does not match the current token owner ID, we're gonna panic. We're gonna say the token owner is different from enforced. Then we're gonna make sure that the token owner ID isn't the receiver ID. So you can't send to yourself because that would be stupid. And then we're gonna log out some information. We're gonna say who's sending to who, and then we're gonna do basically update the ledger, like do the bookkeeping. And then we're gonna clear token approved account IDs.
Yep.
So where is it missing? Where is it suboptimal at the moment that would probably get cleaned up later? I'm just curious.
No, this is fine. Like this is still okay so far. I mean,
I
errors
heard
are
you. I
not.
heard you mutter. I heard you muttering to yourself that it's not.
Oh,
It's not great.
I'm saying errors are not typed. So, like, let's say you're trying to build a front end and figure out why your transfer failed, then you'll be like, so Eugene's saying the token owner is different from enforce. Like, who is the owner then? Or like,
That's what we're
who
always
is
asking
enforcing
ourselves.
it?
We're always asking ourselves. Eugene's saying something. He's talking
Yeah.
to me.
Yeah, or like you transfer it from owner to receiver. Like I called it like how I transfer it on like from this owner. Like it should be from me. So there's gonna be.
Do you know how I do this? I just regex the thing that it says here. So like token owner is different. I just regex and then I do like dot test and then I do like e.toString.
Yeah, exactly.
Real clean, real nice, legit error handling. It's
All
pretty
right. So
it's
so
pretty
next
bad.
thing. So we actually need to handle ownership. One thing we don't have is like revoke all. So we can probably add this as well.
Quick question about standard errors, just like random. Do we have a standard of basically someone is proposing any sort of quote unquote error standards for contracts?
We discussed this, but no.
Okay. Because I could think of a number of errors that are the same, that should probably follow the same pattern, so we could actually kick out an error code, like for example, like
Error code. So
is
the
not
words.
owner, is not approved, not enough balance,
Yeah.
doesn't meet the fee requirement, blah 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 blah, like
Yeah.
not enough storage, not registered,
So
blah,
so
blah,
we
blah.
have a log. We have a log map that's saying how you're supposed to log data, such as, for example, this log where you actually completed an action.
Yeah.
It tells unstructured right now. So if your token ID contains spaces, it will be like transfer it, blah blah blah. Or like you can add add character before the name. That would be cool. So you can do a lot of fun stuff with like when you do format, but yeah, ideally what you wanna is just dump a JSON potential or Borscht field that is described in the NAP, similar how like let's say an event happening on Ethereum, and then you do extra field. So you say NAP, whatever the NAP gonna be for this NFT standard event. Let's say you can name an event. Let's say you can call it transfer, or you can just use an index, something like event one. And then you do two extra fields such as owner ID, receiver, and maybe sender, like who initiated this. And then front end takes this and actually can parse it and display it correctly.
Right. Yeah. I think it's a nice sort of direction.
So similar to errors, I guess you'll have to change asserts because instead of writing an assert, you would have to write something like if not equal, then drop an error in somewhat similar format where you have an app. Why this error happened, then you do like a message if you want to, and extra metadata.
Okay.
Cool. So this one using
So the only method
old...
that we're missing is the add and remove approvals.
Yeah, I think most of this I also added like get token, which I haven't implemented yet.
I think you got rid of that view method,
No,
but it's okay.
it's an NFT core. So also resolver. So resolver is interesting because I just lost all approvals if the transfer failed, so I need to put approvals back. Approval, yeah. Also, I have no idea how hash set is gonna be transferred to JavaScript. It's probably gonna be ugly, and it will convert it to an object with empty keys or something like this, or like with keys only. Or maybe it will do this set too. So
Yeah, I think we better use the vec for now.
but then Vec doesn't really have contains, so I need to use search. But this is fine, whatever. We can change this later. So now I need to on resolve before you actually trying to do the transfer. I need to pull the previous approved token. So I guess I'll have to try to get it here, unless this method should return the previous approvals, which is a hack, and we probably don't want to do this. So I will do token where I can actually get approved account ID. So I'll get the token, expect token, and then I'll get approved account ID, and I'll do to vec. There is no to vec. So I'll do into iter and then collect. I don't even need to tell the type. This is the best. So cool. And we need this because in case a transfer has failed and we need to revert here, we need to set approved. The problem is owner is not the sender because of approval, so you need to say who is the owner. And I probably want to do this here. So I need to change this to be the owner. And I lost it, but so here's a question, like who should be the sender on a transfer call? Maybe we should do all three, then that should be. So on transfer, there should be.
You mean is it the market, the token owner, or the person
Yeah.
who's doing the transfer call?
Yeah, let's just include it, whatever. Not here, but here.
So for example, the person doing the transfer call, is the buyer. Then they do the marketplace does a transfer call, then they end up as the market, and then who else would be involved?
No, so when you receive the tokens as a contract call, then you need to know who sent the token. So let's say a marketplace sent it, and then you want to know who is the current owner is, and this is gonna be the owner ID. So like current owner, token owner, because sender is the one who initiated the transfer. So this can be an approved account, or it also can be an owner. So if you transfer it on your own behalf.
Right, and then owner ID goes into enforce owner, right?
Yeah, but not here. In on NFT on transfer. So this is method that's gonna be called on a receiving contract.
So sorry, is this on the receiving contract? Is this the new owner or the old owner?
Old owner, like previous owner.
I think you want to know the new owner, don't you?
The new owner is you. So when you do a transfer call, then you are the new owner.
Oh, because you're going to arrive back at the contract and you're going to be the owner.
So when you do a transfer call, you transfer into the new contract owner. Yeah. So sender is the one who sent this transfer, and the previous owner is the who owned the token.
And then you can look up the new owner by just looking up the owner.
No, you are the new owner. So like the contract that received the token is the new owner.
Oh, fuck, yeah, sorry.
Yes.
I'm losing it, man. I'm getting tired.
Okay, so we did all of this: sender, owner, clone, owner, receiver.
I'm gonna get a message from Alex. Stop swearing in the videos.
No. So we're recovering the owner. We add in the ownership. We are whatever using hash set for now, so I don't have to deal with this. Metadata stays the same. Tokens are reinserted to store it. Do we do this in a transfer, or did we forget? No, we did. Cool. So yeah, we did the rollback. We removed that from a current owner. It's another transfer. It's kind of weird. No, I am in not. Return token ID from, let's say, receiver to owner. So I can actually move it here, and then I can remove the clone here. Okay, and return false. It means token was not transferred. So this was burned. I don't know, it doesn't exist. Yeah, that's about it. So we modified the transfer call to make sure that the owner is provided. So now we just need to add a few methods that are missing. So approve account ID. So let's get a token. then we should check the ownership. So approvals are only called by owner. So we'll do if token ID dot owner not equal. Well, I guess I can do assert.
You have the self assert, right? Don't you have the self one? Self assert owner?
That's different. This is token owner.
Ah,
So you want to
okay.
do
Yeah.
assessor.
I thought you had a self assert token owner in this repo. No?
No. So
Yeah, okay, sorry.
it was for contract owner.
Right.
So token now needs to approved accounts, insert insert account ID into, I guess. So we inserted this. Now, if this is true, then we need to store it. So we need to insert the token back because we updated the token. So we need to do this operation. If you didn't update it, we can just return false, say no, and this is how it works. Now on the rejection side, revoking side, we can do the same. We can get the token, verify the ownership, say we want to remove account ID as ref. Then if we successfully removed, which I assume is true, whether the value was present in the set, then we need to store it and do this. And finally, if let's say token approvals count ID size is empty, is not empty, then we do clear and we store it. Cool. So that's it. That's all the approvals we need. And finally, you just need to be able to return a token. And this we can do using this.
The only thing I think we missed maybe is the fact that when we add approvals, we want to pay something, don't we?
Good point. Yeah, that's kind of like free for now. But we actually want to do this. And we want to make sure that you get refunds, which is hard now.
I know you have a desire to make it like explicitly perfect, but okay, so I'm just going to suggest something. It's not literally like the most optimal thing, but my suggestion is, given that it's not that much anyways, that we just say that the payable must be the cost of the largest account ID that you could insert. So we basically just say pay for this. And then my only question is there any overhead to the hash set, like beyond what you're putting into the hash set?
No, it just stores the length of the elements, and that's it. So by default,
Okay.
it also stores 0. So that's not my concern. I can implement the storage refund properly. The concern here is on a rollback here. You may have an issue for refunding the storage. Plus, like owner name might change. into a shorter. So when you like nuke the approval IDs, you kind of need to repay. So that's where your suggestion of maximum size per account comes in, which makes some sense to use it.
Yeah,
So
now
you,
even more simple is like and this is like again like getting into more suboptimal but more easy, like I guess easier kind of thing, is like that you basically just have the user like basically like prepay a certain amount. So you basically say, oh, you know, maybe prepay 5 accounts for approvals, and then we just kind of go in and out of those 5 accounts and then refund storage in bulk. But I don't know if that is even useful.
yeah, good idea overall. Yeah, it is kind of like a storage management thing. So we can say, well, approve account is not really a thing. And yeah, you basically require to have payable methods. So let me open another piece and just grab something that's already implemented but need to be updated.
By the way, how do you like this tab 9?
It's pretty good. It is makes it very simple.
Does it run the Rust like sort of, you know, syntax server or whatever it's called, like in the background?
No, it uses deep learning to just suggest. It doesn't run Rust specific. So it has Rust specific model. It just doesn't do Rust analyzer on the back. So
Oh,
so
so
what
it's
it
like
suggests is like token. I start typing, it can like once it figure out idea. So like boom. It's so this is coming from tab 9.
oh, okay.
Or
And
like if I will do
are you in the
assert.
cloud? Are you in like a cloud version, or is this like
No, it's a
installed?
local.
Okay.
So I can do assert EQ and then I can say, oh, I want a token owner ID, and then it will suggest me something else. So yeah, it's pretty good when it knows what it's doing. Anyway, so let's bring the storage manager here, and I have one, just one that you would like. So let's call it storage manager. In theory, like this trait will come from nearest. Oh, I missed the word. Management. The trait for storage management will come from nearest decay crate that we're gonna publish.
So you're going to add a storage manager to the whole contract, and basically, does
Yeah,
that?
I actually wonder if it's really necessary here. So the reason is there's one scenario where it will mess things up without storage manager, or like it makes it a bit complicated. But you can deal without storage manager fine because you know the owner of every storage. So so before we actually do storage manager, let's just ignore it and try to implement it without it. So there's a approval that changes the storage size, and I actually don't need to measure it because I know by how much it changed the storage size. I see the account ID you're adding, and I know the lengths that is required. So let's say storage required is gonna be account ID. Let's get the actual account. And then what's storage required. It's gonna be account length plus 4. So 4 is for the size of the Borscht serialization that is needed per new entry. So if you did this, it means you need to pay for storage. So let's say here you want to say storage, storage refund, and then do storage required. So let's me. So here we actually removing this piece. So if removal is true, then we can do storage as ref length. So storage released. And I will do, well, it also has to be payable, but for the different reasons. So you want to do assert 1 yocto. And this is just, you did not attach anything, I assume, so except for 1 yocto. So I'll do storage required, or like storage released, multiply by balance. No, this is gonna be balance. This storage price per byte, and you can throw 1 yocto on top of this if you want to. So this is we just give away storage. Now what you also need is for revocable, you want to have storage released is going to be something like this. You can do drain potentially. Drain. That count ID. Then you would do count ID lengths. And I need to cast them all into U64 because length is in U size. So I need plus 4. Then I do sum, and that should be storage release. It should be it's bytes because somehow side. Anyway, so this is amount of storage released, and I should also give it away. So I refund it. Okay, so
couple questions.
yes.
Should we assert 1 yocto on revoke all?
On what? Oh yeah, on revoke,
revoke
yes.
all.
Same idea.
Okay. And then I have another question. Up in approve account ID, yeah, exactly. That was
yeah, deposit refund. Yeah, so deposit refund, let's put it into internal method, and this is gonna be so it will do storage used, I guess. What did they call it? Which one is better? Storage required, storage used. So yeah, it is storage used, which is U64 for now, but it's in bytes. So you say how much you need it, storage required. I think we have this in Mint, so we can just grab this from here. And deposit refunds to do. So storage used, we compute required cost, attach deposit. If you attached less, then we will give you a refund. Cool. So it's all good, except now when you transfer ownership, you kind of need to pay, you need to refund existing storage. So we can grab it from here potentially, or we can just call it. But I don't want to do extra logic, so, and I don't need brain like this. So I need this. And internally in transfer, before we do this, I need to do this storage released. So I know the owner, the token owner, and I will probably should just pay them immediately. Except if it's not a final transfer. So let's say we need to roll it back. I need to get these tokens back. Does it sound reasonable? So.
Mm-hmm.
So.
So you calculate all the storage that you've released for this token owner. And then if the transfer wasn't successful, you need to get it back.
Yeah, so let me just return it here for some reason. So now in NFT core, I have my, actually I don't need it because I have it already. So I will just not, so the way I can do this is, yeah, I think the clean way of doing this is return the previous owner. So I'll return account ID and a hash set of approved, or IDs. I'll return the previous approved account IDs and the previous owner. So the way I'm gonna do this is I will take them out of token record. then my token doesn't need to be mutable. Rewrite this a little bit. This is a Rust feature that allows you to basically break down the structure into multiple pieces. So this is what I'm doing. I'm actually this splitting feature into owner ID, approved account IDs, and a bunch of stuff. So I don't need token anymore. I don't have it.
It looks exactly like JavaScript destructuring.
So now I just need to create a new token, use my metadata.
Yeah, cool. And so what you're doing is you're going to pass in the clean new token, and then back to the resolver, you're going to pass the previous owner and the approvals. And in case the transfer failed, you're going to put that back together for that previous owner, right?
Yep.
But if it succeeded, you're going to give the previous owner a refund. Right?
Yeah, exactly. And not only this, so let's say a new owner already enjoyed the token.
Enjoyed. It was a very good token.
And they are added a bunch of approvals already and paid for storage. I know that's kind of like a little weird situation where you like cancel the transfer later, but you did a bunch of actions. So in theory, we should refund it to you. Anyway, so
how would that happen? So
so long as we don't deal with storage management and we like dealing with this brutal approval flying left and right, that actually doable.
So how would
you kind of hold in the you get in the token immediately at the transfer call, so it's yours. You can do whatever you want with this.
Yeah.
So you can do a bunch of stuff. You can transfer. You can add approvals immediately, and then you can say, well, yeah, I don't like this token. Like, take it back. And
so it's like a flash. It's like a flash token.
Yeah, flash loan token.
Okay.
That's how the transfer call works. It first gives it to you, and then
if it fails, it takes it back.
Yeah. So here we have owner.
Let's make the first flash NFT loans.
Then approved account ID. So
I
now
think I think while you're doing that, I'm gonna tweet about this.
refund approved accounts IDs. So I'm gonna just introduce this method that takes two of this and does the work for me.
I think we just came up with something pretty fun. NFT flash minting.
Can I do this? I probably cannot because that is not a. I pass it here. And then I will do this. I will not give you
I
back
just
your
put out a
tenure.
pretty trolly NFT about NFT flash minting. I said don't at us, alpha leak, not financial advice. We'll see who bites. Someone somewhere is probably, you know, doing some drugs, looking at their computer, being like, what? Wondering if they could actually do it. Theoretically, if there was a loan, like a loan-based market that took so you can put NFTs up for collateral, right? So why wouldn't you be able to like basically, like, I guess, mint a clone of your NFT and then get the loan for the clone, so it's a flash loan for a flash NFT, and then go use that to do some market stuff, and then come back, destroy the cloned NFT, and walk away, pay back the loan with your clone NFT. It would be pretty weird.
Well, we can do a cloner. It's probably a contract that takes your NFT, clones it, and then like, yeah, take it back. I don't need it anymore. It's like just. All right.
So in our situation, let's get back to this seriousness of the transfer call. So you send the NFT to somebody, but then it comes back and it wants to do a cross contract call, but there's no. So I guess what you're saying is that because of the asynchronous nature of Near, and the fact that it probably, if the blockchain was really busy, there's a chance that it could not be included in many more blocks. And in the meantime, someone has stuffed the NFT that they don't like full of stuff, right? Or done something. So let's say you had metadata that could be edited, right? So the person who buys it could take the metadata, and if it was originally a long string, they could delete it, get a refund, and then they say, I don't want it anymore, and then the resolver gets hit, and basically you don't get your storage back. So they like robbed your storage.
I don't know about this.
I mean, there's probably some interesting kind of dynamics at play.
I think right now we're coming back to the original NEP4 problems that we faced, but right now we're like more experienced, so we can actually solve this instead of like.
I still say if the metadata is unchanged, then the token size never changes. If the approvals are basically a fixed size,
Yeah, I don't really make a metadata changeable in this, but if you do, then you need to think about like refunded logic for metadata better. So right now, I'm saying I'm gonna hold your payment until you confirm the transfer, until the transfer is fully confirmed. So if the transfer is not fully confirmed, I can still refund the tokens. Not clone. Drop. What? Clear on drop? So here it is. Helper method refund approved account IDs. We're gonna use it again here. So let's say we do revoke. Before we do this, we do refund me current account IDs to the current owner ID. Well, I guess it is a receiver. Then before every true, we actually need to give tokens back. So one way of doing it is we can just put it here in every place. Say, oh yeah, just give it to the owner back, and it should be fine. And finally, I just need to adjust a bit of the gas cost for this stuff, because now it's a little more for Resolver. So Resolver can actually do a transfer, and this transfer might cost you like another base. So let's just drop another 5K. So let's make it 10K. And a transfer call doesn't do refunds internally, so it shouldn't be an issue. And now you have this too, so you don't need to do this. Okay, so I think that's it. So let's actually walk through all the storage related stuff. So to avoid duplicated logic, I can say, so just maybe I should have wrapped approved account bytes. So rename this to something like approved account bytes, or like bytes for approved account. And put it here, because in case this stuff changes, yeah, my tab 9 is probably down because it doesn't suggest me this beautiful new word name that I created. Oh. The only time you keep one Yoctanier is when you revoke all. You don't get one Yoctanier back, because this method is saying it's like reuses the code, so it doesn't give you one Yocta back. Cool. I think that's it. Let's try to actually compile it.
Why don't you actually get one Yocta back?
Because this method doesn't let you give Yocta back. It's used in multiple places and doesn't want to spend extra gas on giving Yocta.
All right.
It actually probably a stupid idea to give Yocta anyway, because it will burn more gas to give this Yocta. So from now on, I'm not giving Yocta back. So in all my implementation, I will keep this Yocta, because the gas amount that you will burn on +1 increment is higher than 1 Yocta, because one gas is like million Yoctas, and we're doing like increment operation, which is at least 2. So
Are you looking? You got any projects that are building on Near that you're looking forward to?
I've yeah, we've reviewed Metapool today and at the live contract reviews, and you were there. So I'm more interested in what Ilya wrote with multi-swap. So I think this is gonna be a cool balancer implementation on Near without EVM.
So it's basically balancer on near, but without EVM. It's kind of like a very basic version of our own kind of Uniswap.
Yeah. Oof. 1 million errors. So what did I do? This internal as bytes here. Okay.
Is there any risk to you just are like editing the hash set manually like that?
Where?
Like
Oh,
you're in the unordered, sorry, you're in the unordered set. Like, is there any risk to you just like doing that?
no, hash is somewhat unique, so we should be okay.
Why did you hash the account ID? Why didn't you just use the account ID itself? Isn't it unique enough?
Well, account ID can be from like 2
Oh, it can be
characters,
bigger, right?
or it can be 64. So this one makes it fixed size and balanced. So
Got
like
it.
we balance approvals map. So you cannot really attack us by introducing like approvals to non-existing accounts.
Got it.
This, I have this, and I don't need this. Oh, maybe I can compile like this. Can I?
We still need a
No.
UI for near swap, right?
I guess I haven't tried it. So this owner ID. What? I don't need multi-sig. Stop it.
Oh, near swap is Robert's version, right? Sorry, I thought you were talking about Ilya's version.
Yeah, Ilias version is multi-swap.
Multi swap. Oh yeah, great name. Not confusing at all.
Where did you find the back type in trade?
We're
Okay.
already getting some. We're already getting some some interest in our NFT flash minting. People are like, someone wrote, "Color me intrigued." It's like the guy from Open Law. Oh man, it's just a big troll. It's like we're not doing it at all.
The
I love to come up with ideas and just tweet out like an idea in like a 3 or 4 word tweet and just blow people's minds, and then they start thinking about it and they're like, what if it's possible, man?
can borrow.
The trouble with the crypto space is that there's more idea people than there are like engineers right now, or like builders, or people that even understand the technology. So like there's more people that understand, like the funnel is basically like, you know conceptual people, and there's like, it's either a funnel or a pyramid, however you want to look at it. But basically, there's like a huge, let's do a pyramid, huge basis of conceptual people that sort of get it. They get the idea of like crypto. And then there's like a bunch of those people that are creative, and there's a huge pile of those. And then there's a bunch of people that actually understand the limitations of the technology right now at this moment, right? And they're still not even engineers. And then you keep going up the stack. There's like people that build like wallets, and then you go way up the stack, and there's like people who writes smart contracts and dApps and shit. And then you go up to the very top, and there's like protocol engineers.
No. Then you go even higher, and then Anton Bukov, who like wrote the 1 inch.
Oh yeah, you go to like God mode, right? Just
Yeah, yeah.
floating above the pyramid in like a stormy cloud. Yeah, sure. Somebody needs to make that graphic actually. Like you have like the pyramid, but and then all I guess the all the people that are like just hodlers, they're just like nameless, faceless villagers, like in the shadows with like flaming torches, you know, like circling around the
It
pyramid.
does
Like,
compile. It does compile.
ah! So it compiles.
Yeah. So okay, ship it. Let's meet NFT.
Ship it. Let's throw it in prod. Let's go.
Let me first commit this. Update the approval system.
So what I'm actually gonna do with this, Eugene, I'm gonna actually write all the launcher like app code around this, like a server, an owner, like a person who launches NFT contracts.
Yeah.
Just the same thing I did with the FT launcher. Like, so I don't like I don't have a factory. I actually wanted to ask you about this. So I don't have a factory that launches fungible tokens like on chain factory. I basically just I basically just provide client side stuff, whether it's a server code or whether it's like whether it's actually front end code, like somebody signs in with their near wallet and says, I want to launch this contract. So I basically just provide a bunch of example code for somebody to just launch these contracts from the bytecode itself, right? So somebody can go through, they build their contract into Wasm, and then they just, you know, let's say it's server side, the server just loads the Wasm and creates an account using the I actually use the link drop contract, but I just use the create account flow, wait for the
Okay.
account to be created, and then I just basically deploy the contract. So I guess my question is, do you see any drawbacks to building like launchers in this way, like where there's sort of application side factories?
Application side factories are kind of problematic because of they can deploy different types of contracts and need to be enforced by the country. Well, like no, actually it's fine. Like, you can check the hash later on your end once you deploy it.
So
it
what you're
is
saying is you're just basically saying that the server needs to be careful that somebody didn't like jump inside their infrastructure and basically swap out the WASM or something, right?
this is as well, but also like post factum, you want to probably just check that the hash matches to what you expected when you're deploying it.
Yeah.
Also,
Otherwise,
another problem is like, let's say you're doing this on a mainnet and you need to issue a transaction that goes to have to be signed by the ledger. Well, that's gonna fail because you cannot really sign 200 kilobyte transaction with the ledger.
so you need to deploy on mainnet and you're using a ledger and you basically trying to deploy contract. And that's the problem.
Yeah, because in a wallet, let's say I'm using ledger, you're saying like, oh yeah, Eugene, go deposit like 20 near, and then, well, not 20 anymore because of new storage, but deposit some like 3 near, and then I'm gonna deploy this piece of code. Like, if you ask to sign this enormous transaction through a wallet URL, it will fail. So you can only do this through the post request, which wallet I don't think supports because it's a React app or something like this. So if you want to deploy a contract from the front end,
No, I did it. I mean I did it with the wallet. I in my token launcher, basically what I do is I call create account and I call create account on the, you know, like the dot .testnet, the actual testnet account. So then I come back to the app, and I have the full access key for that account in my local storage. So basically,
I see. Yeah, then this is fine. Yeah, this is fine.
Yeah. So I'm basically just doing it in like 2 steps, but that's if I'm doing it on a front end, but that's not going to be used by anyone, Eugene. Like people are going to use a server, right? So they're going to use a server with some account that they put the secret for the key for the account in their environment variable, and they basically boot up the server, and they say this is my deployer account, right? And then that deployer account is going to call create account and then deploy the contract bytes to that account.
Matt,
and then
I need you to use this account. I'm going to send it in a chat. If I can find the chat here. Boom. It's on testnet. So I just deployed an NFT.
Where did you send it to me?
Zoom
Discord?
chat.
Oh, in the
okay, let me send it to Discord as well, so you don't lose it.
No, I'm going to the chat. Okay, what am I calling on it?
You can call whatever you want, because I already initialized it for my name, so you can like try to do anything from all the methods that we did. So let's try to mint something. So I will mint a new NFT. Let's actually.
I need to log in first. Hold
on. NFT mint, and then we're gonna do token ID. So I'm gonna call it that token, and then the metadata is gonna be
Okay. I'm almost there.
Oh, I didn't attach near for storage, which is 0.08 near. So let's attach the amount. Is it amount? The API is the worst. 1 near. I attached 1 near, and I made a token.
Is it just like amount equals 1? It is, right?
Yeah. NFT token. Token ID.
Hey, will you be able to see my token?
Well, you cannot really mint it.
Why? Because I'm not the owner?
Yeah.
Oh, man. Okay, so
let me transfer it to you.
I'm gonna call your contract, but what can I call?
Oh, well, actually, let me not transfer it to you first, but I'll do the approval. I will add an approval. NFT approve account with token, and account ID is gonna be.
Did you already commit this?
Yeah, committed and pushed. Oh, I need to attach balance again, so it's gonna fail. I need, let's say, amount 1. Let's see.
So the token ID is the token, right?
Yeah. I hope it refunds me money because I can probably look at my account ID to see how much near went to where. Yeah, it doesn't. Oh, maybe new indexer.
I got your token.
What?
Yeah, I viewed it. I did a view call. I got your token.
Okay.
And you rickrolled me. All right, that was good.
Okay. So I added.
That was the first near NFT rickroll. That was good.
So let's actually transfer it to you from Meta. So
yeah, and then I'll just view it again, and I can see myself as the.
I'm gonna use Meta, and then I'm gonna do NFT transfer, and I'm gonna
Did you approve Meta?
Yeah, I just approved Meta, but I'm gonna enforce the Meta owner for now. So you also need the receiver ID first. That's gonna be, what's your testnet account?
md1.testnet.
And I will enforce owner ID. And I'm gonna obviously say that I'm Meta, and then memo. Really good video.
Yeah.
Oh, it needs to be payable. It needs 1 yokta. Amount.
This is painful, right?
It is a bit of inconvenience. Okay, the owner is different from enforced owner, so that worked. So now let's check one more. I think I have more accounts. I can say, oh, I can call it from this account. It's saying unauthorized. Great. So now I just need to, let's say, enforce the correct owner. You should get it. Perfect. Transferred the token from Eugene the Dream to MD1. Memo, really good video. So we just sent a video on the internet.
I'm viewing it now, just like pulling it.
Okay.
Okay,
Yeah,
I'm the owner.
You are the owner.
Yeah.
And you don't have approved accounts anymore.
Yeah, approved accounts is length 0.
So what I should see is Meta. No, Eugene the Dream.
All right, that was my dance break.
So Eugene the Dream should get some
sunglasses?
refund. Oh, Eugene the Dream got refund. It just doesn't display in the testnet.
Did you see my glasses?
It's better because like your eyes were like disappearing during the video.
Yeah, I know. That's that green screen.
A little creepy.
Like I can do it.
Okay, let's see if I on a testnet wallet for
Guess
Eugene
what else
the Dream.
I got the
spoon?
spork from East Denver. It's a spork.
Oh, look at this. I got all my refunds in the wallet. This is really cool.
So let me recap, because you attached one near when you added the approved account IDs. So you just paid for like a blanket amount of account IDs. Like you didn't have to attach the full one near, right? But you got to
No. Yeah.
so let me ask two questions. When you added the first approve account ID to approve the account that could send to me, you attached one near, and then did you get a refund for everything except the
Yeah.
account ID storage?
Yes.
So you got that first refund, and then the second refund you got was when you actually transferred to me, right?
Yeah, I can send you in a Slack the
Slack.
activity. I guess you're not on Slack in whatever we use,
I actually
Discord.
I haven't opened up Slack for like 3 days. I think I don't know anything that's going on.
That's good. Good.
I
Sometimes.
gave up on it, man.
Look, so I send you a screenshot. This is from my testnet wallet because Explorer doesn't display this beautifully on testnet yet, only on mainnet. And this is my refunds. So the first I called, I guess I can stop presenting.
Yeah.
And I can open this in a separate window so I can explain what I'm talking about.
And then we can head out after. Oh, I see. Yeah.
So the first on the bottom is a new. Then I called mint and I didn't attach, so it failed. Then I called mint and it succeeded. And here's a refund that I got. So I attached one for minting. Then I did an approval, it failed. I did an approval and attached one, I get a refund. And then I send it from Meta and I got a refund for my approved Meta account when Meta transferred on my behalf.
That's fantastic.
It all seems to be working. We can probably use simulation testing for this to cover this weird case scenario with like 2 refunds. In the bottom of the, when we do a bunch of refunds and charging.
All right. I'm gonna stop recording.
Cool.
And yeah.